Hello, everyone. Welcome to today's session where we're looking at the last and final portion of Learning Unit 5. Today, we're looking at how to carry out a hypothesis test for a single proportion. So, remember, we said that the steps that we follow are pretty much exactly the same as with the hypothesis test for a single mean, where the first step is to write out your null and alternate hypotheses. The second step is to determine your region of rejection. The third step is to calculate your test statistic. The fourth is to compare your test statistic to the region of rejection and acceptance. And then the fifth is to make a decision and conclude. So we're following the same 5 steps. The only difference here is that we're working with proportions, which means that what goes into our null and alternate hypotheses will say the null will have that. Remember, for a proportion, the symbol pi denotes the population proportion, and the letter p, small letter p, denotes the sample proportion. So in our null and alternate, we must always use the symbol of the population. So it will say that either according to the question, we'll say that pi is equal to, or sorry, pi is equal to or not equal to. Alternatively, we'll say that pi is greater than and equal to or less than in the alternate. Alternatively, we'll say that it is less than and equal to or greater than in the alternate. So any one of these three can possibly be the type of test that we're looking at. And then also, again, since we're working with proportions, you'll find that the way in which we calculate the z value changes, where it's now calculated as p minus pi since it's a proportion. So p minus pi over the root of pi multiplied by 1 minus pi over n. You'll find that this is the same formula that we had used in Learning Unit 3 as well and part of Learning Unit 2. So nothing familiar and nothing unfamiliar to you here. And the rest of it, as we said, is pretty much the same. Also, with your single proportions, we only work with z values as your critical limits. So the table you'll see I'll pull up in a second is not the one in your appendix, it's the one that you will find in your textbook. And again, you won't need to calculate a t-value to use as your critical limit. So let's have a look at the question. There's 2 questions we'll be going through today. There are 2 different types of tests as well, just to show you the different possible ways that you can be asked this type of question. So the first question says, due to a very high staff turnover rate, only a small percentage of top management in most companies have been with the same company for a long time. According to an estimate, 19% of top management in most companies have been with the same company for 15 years or more. So they're saying that this general figure of 19% is the percentage of top management that has been with the company for 15 years or more. And so this is a general figure which says to us immediately that this would be your population figure. And whenever it's a percentage that we're working with, we convert it to a decimal. So it would be 0.19 in this case. And that is the value of pi, your population proportion. And then they say to you that an employment agency wanted to check whether this percentage is still accurate or if it has changed. Random samples of 500 top management employees were taken. So your N value is 500. And the sample showed that 15% of them have been with the same company for 15 years or more. So, of the 500 employees, the percentage of or the proportion of management that has been with the same company is 15%. So, that would say to you that your population figure, the letter P, is equal to 15%, which as a decimal is 0.15. And then they say to you to test this at a 1% level of significance, whether the percentage has changed or not. So the first thing we're going to do is write out our null and alternate hypotheses. And again here, since we're working with proportions, the symbols we use in the null and alternate hypotheses are those of the population. So the population proportion symbol is pi. Since they're saying that they want to know whether the percentage has changed and the percentage was 19%, our null will say that it's either equal to 19% or 0.19, or it has changed and it is no longer equal to 19%. So this is a null and alternate hypotheses, which said to us that since the equality sign is in the null hypothesis, this is a two-tailed test. Then we have step 2, which is to determine your region of acceptance and rejection. Since it's a two-tailed test, there are two critical limits, and anything inclusive of those limits or within them are your region of acceptance, and anything beyond to the right, beyond the limit on the right, is your region of rejection, and anything further to the left is your region of rejection as well. So now we need to know what figures go into this in terms of the critical limit itself. We need to know two things here, what type of test it is, which is a two-tailed test. And then we'd also need to know the level of significance, which in this case I said to you was 1%, which as a decimal is 0.01. So we then would need to look at the information provided in your textbook, which is the table that looks like this. You're looking at a two-tailed test, so any one of these three, and at a 1% level of significance, your critical limit is 2.58. So when we draw up that bell-shaped curve, what we're saying is that the positive 2.58, which is why we have a plus and a minus sign here, says to you that on the right-hand side, it is a limit of 2.58. And then on the left-hand side, it's going to be a negative 2.58. So let's go back to the question. Okay, so as you can see, once again, just to write out our null and alternate hypotheses. So the null said it was equal to 0.19. The alternate said it was not equal to. We said it was a two-sided test or two-tailed test. And when we drew up this bell-shaped curve now, we know that the critical limits are a negative 2.58 and a positive 2.58. And so when we write these out as words, and remember I said to you that you'd only be required to write out the rejection region. So obviously, if you prefer to write it all out again, like I had shown to you in some of the previous examples, it's perfectly fine as well, just to help you. But the mark allocation comes from only stating the rejection region, so that here in this case, it would say the rejection region, you would reject the null hypothesis if the Z statistic is greater than 2.58 or if it's less than minus 2.58. Okay, so these are regions of rejection. We then go to the next step, which is to calculate your Z value, which as you know is P minus pi over the root of pi multiplied by 1 minus pi over n. So here your p value, remember, was 15%. Your pi value was 19%. So this is P, that is pi, and your N, your sample size, is 500. So into the formula goes the p-value of 0.15 minus pi is 0.19. Then it's over 0.19. So remember pi multiplied by 1 minus 0.19 over n, which is 500. This would give you a z value of minus 2.28, which you would then compare to your region of rejection and acceptance. And as you can see, minus 2.28 would fall very close to the limit on the left, but it still falls into your acceptance region. So when you conclude, then you're going to say that therefore we do not reject the null hypothesis, or you can say that we accept the null hypothesis. And if we're saying we accept the null hypothesis, so I'll just write it here at the bottom. We do not reject. Sorry, I didn't leave a space here, or it just became too close since I'm trying to fit it all in. We do not reject the null hypothesis, which indicates that this is true. So we accept this, which means that what they're saying here about 19% of top management in most companies having been with the same company for 15 years or more is actually true. So you'll say that we don't reject the null hypothesis, which indicates that 19% of top management in most companies do stay with the same company for 18 years or more. So you'll state that exactly what the question had said. 19% of top management in most companies have been with the same company for 15 years or more. So this is what you'll state beyond the accepting or rejecting the null hypothesis. So I'll give you a second and then I'll continue with the next example. Okay, so let's have a look at the next example. So this says to you that a producer of frozen orange juice claims that more than 52% of all orange juice drinkers prefer their product. So they're saying greater than 52%. Now remember, this immediately should signal to you that this statement that they had claimed, this cannot go into the null hypothesis, because remember, a defining characteristic of your hypothesis is that the null must always contain the equality sign. So immediately this signals to you that our null will say the opposite of this. So we're saying pi and pi. Here for the first one, your your null hypothesis, it's going to say the opposite of this, which is, since that is greater than 52%, it's going to say less than and equal to. And then this claim that's being made of it being greater than 52 will go into your alternate hypothesis because it didn't have the equality sign attached to it. And then in terms of the 52%, you'll write it as a decimal. So that would be 0.52. So it's very easy early on to tell what your null and alternate hypotheses will be simply by just looking at the question and the wordings that they use in terms of the claims being made. So then they say that to test the validity of this claim on the 10% level of significance, so A here is equal to 10% or 0.10. A competitor samples 200 orange juice drinkers, so N is equal to 200, and he found that only 95 prefer the producer's brand. So what they're saying here is that P is equal to 95 out of the 200. So here your p-value is 95 out of the 200, which you must show the working of whenever you have this type of question. Your value of p then to two decimal places is 0.48. So now you have the value of p, the value of pi, as you can see from the question, from the first statement as well, is 52%. So p is 0.48, pi is 0.52, and n is equal to 200, which means we have everything necessary that goes into the testing for the specific claim that is being made. So we have p, pi, and the value of n, and they said to you to use a level of significance of 10%. So again, the first thing that we are going to do, which we have already done here, is to write out your null and alternate hypotheses. And as you see, the claim that was being made was that it was more than 52%. However, since the more than 52% didn't include the number 52 itself, so it didn't have the equality sign, it would be your alternate hypothesis, and then the opposite of this with the equality sign would be your null. So less than and equal to sign would be in your null hypothesis. So we have your null hypothesis written out for you. The second step is to write out or determine your region of acceptance and rejection. So in this case, remember, you need to know what type of test it is. If you're having a difficult time with that, just look at the sign, the alternate hypothesis. If it's the not equal to sign, that means it's a two-tailed test. So two-tailed. Again, if it is the greater than sign, like in this case, it is an upper-tailed test. And if it's the less than sign, it is the lower tail test. So here it's an upper tail test, which means you have one critical limit on the right, everything inclusive of that value and less than it, your region of acceptance, everything beyond this, which is everything greater than it, is your region of rejection. So here you're going to now determine what the critical limit is itself. You need two things. You need to know the type of test it is, which we know is an upper tail. And then we also need to know the level of significance, which in this case is 10% or 0.1. So let's go to the table with the Z values. We're looking at an upper tail test, so either one of these. The level of significance is 10% or 0.1, and so your critical limit is 1.28. So when we draw this up, it is a critical limit of a positive 1.28. So your region of accept is anything inclusive of 1.28 or below it. Your region of rejection is anything greater than 1.28. So let's go back to the question. So here, just to write out your null and alternate again, Your null would say that pi is less than or equal to the 0.52. The alternate will say pi is greater than 52%. And then this is an upper tail test. Your region of acceptance and rejection. Your region of acceptance is 1.28, which we got from the previous table. So 1.28. We need to write this out in words. So you will reject the null hypothesis if the Z statistic that we will calculate in the next step is greater than 1.28. So we've written out your region of acceptance and rejection. The Z value is calculated, remember, as P minus pi. So P is, we said, we calculated was 0.48. So P minus pi is 0.52 over the root of pi multiplied by 1 minus pi over n, which is 200. And this would give us a value of minus 1.13. We take this, go to your diagram, and look at where does that fall. It's a negative value, and remember your negative values fall further to the left. So this would be your region of acceptance, and you'd say that therefore we do not reject the null hypothesis, or you can say we accept the null hypothesis. So we do not reject the null, which indicates to us, and here again, we'd look at what the null says and what the alternate says. If we're saying that we don't reject the null, that means we're saying that the null is true. So the null is saying that it's actually 52% or fewer of people that prefer orange juice from this particular producer. So it's actually fewer or equal to 52% people that prefer their product. So we'll say that this indicates 52% or less people prefer this orange juice, or you can say this produces orange juice. I'll just write OJ, just an abbreviation for it, but you can write that out in full. So that is just the different types of tests that you will come across with your proportions. And I hope this has been useful to you. Please, please, please practice these type of questions. They are extremely useful to you. This is a section that is very, very commonly asked. The different types of tests as well. Look at a two-tailed test, an upper tail test, a lower tail test. Look at the 5 steps that go into the hypothesis testing process. Look at examples where it is a single mean for which we're carrying out a hypothesis test, but where the population standard deviation is unknown. So please pay careful attention to that. Please also pay attention to the wording that they use. So look out for keywords like more than, less than, at least, at most, and so on. And I'm sure you will do perfectly well with this learning unit. Thank you guys. I will see you again in our next session where I will be looking at the first portion of learning unit 6, which is the chi-square distribution for test of independence of association. Thank you guys.